Okay, on this assignment, right here on the first one, it says review of the scale factors, solve the following using the scale factor. Now, you can do it a couple of ways. One way that you could go through and do it is I could look and see what times 5 gives me 35. Well, it would be 7. So whatever I multiply by the bottom, I have to multiply by the top. It would be times 7. 2 times 7, that would be 14. And you'll have to excuse my writing just because I'm writing with my right hand and I'm left-handed with the mouse. So the other way, though, that you can go through and do this problem is by ratios and proportions. And what you would do on that, let me see if I can erase this here. What you do here is you'd go and you'd multiply these two numbers, which would give me 70. And then you would divide by this number right here. So I divide by 5. Well, up here, same type of thing. You could do it either way. If I'm looking here, what do I have to do to 7 to get to 1? Well, you would divide by 7, or 1 times 7 is 7. So you could do the opposite here and go 4 times 7 to get R, and R would be 28. When they're already set up like these, I tend to find it a lot easier to do the ratios and proportion, the cross multiplying. So I would multiply these two together and get 28 divided by 1, still giving me 28. So on the next problem, I would go here and we can go with scale factor again. Oh, it's the wrong one here. Let's see. Scale factor. What do I have to do to 75 to get to 15? Well, you take 75 divided by 15 and you'd get 5. So you would right here divide by 5. Or you could look at it as 15 times 5 gives you 75. Well, right here, what number divided by 5 is 9? Well, 9 times 5 is 45. Or you would cross multiply. Same thing, 75 times 9 divided by 15. On the next one, same thing here. You should have figured out what do you have to do to 3 to get to 27. You would multiply by 9. Well, up here, 1 times 9 is 9. Right here, what do you have to do to 2 to get to 12? Multiply it by 6. So I would go here, 11 times 6 gives me D. So my answer here is 66. Next one, what do you do to 24 to get to 4? Well, you divide by 6. And 4 times 6 is 24. So if I take this right here and divide by 6, it'd be the same as 12 times 6, which would give me 72. On the next one you had on your paper, you had this right here, this scale factor. And you find the matching sides. Well, what are they doing to 13 to get to 26? What are they doing to 5 to get to 10? Well, they're taking it times 2. So I should take 12 times 2. And so that means my x, this would right here would be 24. On your next one, right here you would go and you'd find your matching sides. Well, let's see, 7 and 14, 6 and 12. It looks like they're multiplying by 2, so I would take 4 times 2, which would give me 8. Number 3, after all those little sub-problems, now we're on number 3. And it wants to know which of the following equations can be used to prove that the trapezoid STUV and trapezoid NOPQ are similar. Well, you would go through and find the sides that match up together, like 15 and 5 go together, and 12 and 4. And what you're trying to do is, okay, so say I got 12 over 15. So I take 12 over 15. Okay, I'll take these two right here. If I put 12 on top, then which one over here has to be on top? Well, 12 and 4 match up. So when you've got 12 over 15, and that equals 4 over 5. Well, if it is well, first off, this would be my answer right here, B. But to know if it was similar or not, you would look if I took 12 divided by 3, it would give me 4. Well, this would need to be the same in order for it to be similar similar figures. And it is, because 15 divided by 3 is 5. The next one, they want you to find this missing side right here. You can go in and set it up and figure out a ratio proportion, or you can do cross multiplying. But I've got 6 over 15, and the matching side is that x, I don't know what it is, over 10. For me, it's easier to go through and I would cross multiply right here, and I would get 60, and I would divide that by 15. 60 divided by 15 is 4. That would be the shadow. Or, I'm sorry, the height of the child. The height of the child right here. The next one, right here, wants to know the length of segment AC. Well, AC is right here. I have these two legs, and this is they're talking about it being similar. Well, we have, what do you have to do to 12 to get to 6? You divide by 2. So I'll take 10 divided by 2 and get 5. So now I've got these sides, but I don't have this one right here, and they want to know about them being similar. They're trying to find the leg segment, the length of the segment AC and DF. So what I'm going to have to do here is I'm going to have to do the Pythagorean theorem, a squared plus b squared equals c squared. So I'm going to have 12 squared plus 10 squared, and that's going to equal c squared. So looking at that right there, when you put that in the calculator, you have 144 plus 10 squared is 100. That gives you 244, so you need to take the square root of 244. When you do that, you get 15.62. Then, over here, I would have 5 squared plus 6 squared. And that equals c squared. So I'd have 25 plus 36 equals c squared. So this is 61. So to get c, I need the square root of 61, which ends up being 7.81. This one here, they are similar, and they're trying to find this length right here. Well, let's put this 55 over x, and then 55 matches up with 40, so I'm going to set it equal to 40 over this bottom one, which is 50. Now what I did was, I went, let's see, let's get another color here. I multiplied these two together right here, and took 55 times 50, and got 2,750. And I divided that by 40. And got 68.75. And that would be that side. Now on these practice problems right here is going to be the Pythagorean theorem. This one is actually a special triangle if you recognize it. But if not, I want to remind you that the side across from the right angle is C. It's the hypotenuse. So I have a squared, oh, that's a big A, plus b squared equals c squared. So I have something squared. Doesn't matter if you use a or x. plus 4 squared equals 5 squared. So what you're actually doing, so once I go through and do this, you can find the shortcut and know that you're going to take the c squared minus the a squared. So I'm going to actually take 25 minus 16. When you do that, you get 9. And to find your missing side, you're going to take the square root of 9, which gives you 3. So your answer is 3. On this one, I'm trying to find the hypotenuse. So I'm going to take 8 squared plus 15 squared, and that equals c squared. Well, if you will go, you're going to have 64 plus 15 squared is 225 equals c squared. If I take 225 plus 64, I'm going to have 289 to be c squared. So now to find c, you have to take the square root of 289. And when you do that, your answer is 17. Number 3, same thing. We're looking for the hypotenuse. So I'm going to have 14 squared plus 48 squared equals c squared. I have 14 squared plus 48 squared. You put that in there together, you get 2,500. Then you'll go and take the square root of that. So I have the square root of 2,500. Which is 50. So my missing side is 50. The next one, okay, this time I have C. I have the one across from the right angle. So I'm going to have something, either a squared or b squared. I don't know which one it is. It doesn't really matter. Plus 36 squared, and that equals 39 squared. So let's see here. I've got x squared and 36 squared is 1,296 equals 39 squared, which is 1,521. You'll subtract those two amounts. So 1,521 minus 1,296 gives you 225, and you'll take the square root of 225. Which you get 15. On number 5, right here, you're trying to find how long the string is, which is c squared. So you'll take 15 squared plus 20 squared, and that equals c squared. So when you add those together, 15 squared plus 20 squared, you get 625. And that's what equals c squared. You take the square root of 625, and you get 25 as your length of your string. On the next one, on number 6, it says a ladybug runs the distance of across a rectangular patio. So let me, oh, nice rectangle, huh? Let's draw one the best I can here. Now, the ladybug goes across a rectangular patio from one corner to the opposite corner. That means that's that. That means it's the hypotenuse. Okay, so there's my 18. The length of the patio is 12, so I'm going to make this 12. What is the width? I don't know this. So I've got x squared plus 12 squared equals 18 squared. Well, x squared equals, or yeah, we'll just do equals because you're going to take 18 squared minus 12 squared. And that gives you 180. So to find your length, take the square root of 180. Which will give you 13.4. Well, let's use a green one. Okay, so on the next one, there's just two more now. Okay, there's two light poles. They are both 15 feet apart. So from here to here is 15. Now it says that the taller pole is 5 feet longer than the shorter. So this right here is 5. It wants to know what is the approximate distance from the top of the pole down to the larger one to the smaller. So I'm going to go here. I'm looking for C. So you're going to have 5 squared plus 15 squared, and that equals C squared. Well, 5 squared I know is 25 plus 15 squared. When I add those together, I get 250 is C squared. So now if I do the square root of 250 to find C, square root 250 is 15.81. The next one, okay, it already has the picture drawn for you. Here's the hypotenuse. I'm missing side. I have 7 squared plus x squared equals 18 squared. So now I have 18 squared minus 7 squared, which actually, so x squared is going to equal 275. So if you take the square root of 275, you get 16.58. Well, the closest answer, as soon as I finish writing it, the closest answer for us to use is right here at 17. And that's your answer.